In this video, I'm going to show you how to use integration by parts to solve integrals involving logarithms. The trick is to set u as the logarithm part. That way when we differentiate, the logarithm will go away. So in this integral, we're going to set u equals ln of x to the fifth, and then we'll have u prime equals 1 over x to the fifth times the derivative of the inside, 5x to the fourth, which just comes out to 5 over x. And then the v prime part will be our x squared. So then v is the antiderivative of that, and that's just 1/3 x to the third. And then we can plug that into the rest of our formula for integration by parts. U is natural log of x to the fifth, and then v is 1/3 x cubed minus the integral of v again, 1/3 x cubed times u prime, which is 5 over x dx. All right, now we can just simplify this a bit. So this is just 1/3 x cubed ln x to the fifth minus, inside this integral we get 5/3 x squared dx. And then this integral we can evaluate. That's just minus 5/9 x to the third, then plus some constant, so we get 1/3 x third ln x to the fifth minus that plus the constant. And that's our final answer. That's the solution to this integral. Here's another example, and the trick is still the same. We're going to choose u as the log 3x part, and then we'll have u prime equals 1 over x natural log of 3, and then the other part, the x squared plus 2, will be our v prime. And to get v, we just take the antiderivative of that. We get 1/3 x cubed plus 2x. And now it's just time to substitute in the right hand side of our formula here. So u is log 3 of x, and v was 1/3 x cubed plus 2x, and then we've got minus that integral of v again, 1/3 x cubed plus 2x times u prime 1 over x ln 3 dx. All right, so now let's simplify this a bit. So this is just 1/3 x cubed plus 2x log 3 of x minus, let's bring out that 1 over ln 3 times the integral. Everything gets decreased by a power because of the x, so 1/3 x squared plus 2 dx. And we'll write this again, and we can solve for the integral now. So just bringing down our initial terms, and now let's solve for the integral. So that's 1 over ln 3, and the integral evaluates to 1 over 9 x cubed plus 2x plus some constant. And now we can go ahead and simplify one last time. We're going to keep the left terms the same, but on the right terms we'll distribute that 1 over ln 3 to both of these. We'll put them over a fraction, so minus 1/9 x cubed plus 2x over ln 3, and then the c, since that's just a constant, then c over ln 3 is still just a constant, so we can just put a plus c at the end. And there we have it. There is our solution to that integral. Our final example is a little bit trickier because we still want to choose u as the natural log, but then what do we choose v prime as? There aren't any other terms in this integral. So the trick here is to rewrite the integral with another term. We're going to have 1 times natural log of 1 plus x squared. That way we can keep our choice of the natural log as u, and then 1 can be our v prime. So u equals natural log of 1 plus x squared, which means u prime equals all over 1 plus x squared, and then times the derivative of that, so just 2x on top. And then v prime equals 1, which means v is just x. Alright, so now we're ready to substitute into the right-hand side. U is just natural log of 1 plus x squared, and v is just x, then minus that integral of v again, which is just x, times u prime, which is 2x over 1 plus x squared, all dx. Alright, now we can simplify a bit. So this is x natural log of 1 plus x squared, and then we'll bring out that 2 outside the integral, so 2 integral of x squared over 1 plus x squared dx. And this integral, why don't we do this on the side here? We'll bring this over here. Integral of x squared over 1 plus x squared dx, we can express that as just integral of -1 plus x squared over 1 plus x squared dx, because these two terms cancel to 0. And then that becomes -1 over 1 plus x squared plus 1 plus x squared over 1 plus x squared is just 1 dx. So that's negative arctan of x plus x. And we'll just substitute that back into the integral part. So we've got x natural log of 1 plus x squared minus 2 integral of negative arctan x plus x, and there's going to be a constant at the end, so we'll just put it here. Let's put a divider. Alright, and now we just got to simplify. Let's distribute off this -2. So x natural log 1 plus x squared, and then plus 2 arctan x minus 2x plus some constant. And there we go. That's our solution to this integral. In the future, we'll tackle even tougher integrals, where we have to apply integration by parts more than once.